In this video, we're going to discuss how we actually graph quadratic equations. So now that we know how to solve all types of quadratic equations and even equations that are quadratic in form, we want to be able to graph them. All right. All quadratic equations have special properties. To help us see these properties, I'm going to graph the quadratic equation y equals x squared and y equals negative x squared. I'm going to graph these by plotting points. And what I did, you know how in Math 101, if you've taken Math 101 here at Midlands Tech, you create an XY chart when you first start learning how to graph lines, and you pick some values for X. For instance, you can pick -2, -1, 0, 1, and 2. And then you plug the values into your equation, and it'll calculate your Y value. Well, I'm going to do that for both of these equations. I'm going to start with the equation y equals x squared. I already have my XY chart right here. What I'm going to do is I'm going to plug in -2 for x, right? All I have to do is square it, and then it'll give me what y equals. So remember, when you square something, you multiply it by itself. So -2 squared will give us a +4. -1 squared will give me a +1. 0 squared will give me a 0. 1 squared will give me a 1. And 2 squared will give me a 4. That means I have 5 ordered pairs. My first ordered pair has a x coordinate of -2 and a y coordinate of 4. So when I go to graph, from my origin go to the left 2 and up 4, I have my ordered pair. Okay, my next ordered pair is -1, 1. So I get the ordered pair here. I have the ordered pair 0, 0, which is here. The ordered pair 1, 1, which is here. And the ordered pair 2, 4, which is here. And so what this does for me, I'm going to zoom out just a little bit, is that it gives me something that it looks kind of like a U. And that's actually what the graph is going to look like. And so I'm going to try to graph this without being too messy. It's a little hard to graph with the tool that I'm using, but you get the general shape that is kind of U-shaped. All right, I'm going to do the same thing for y equals negative x squared. I already have me a chart already picked. I chose my x values to be -2, -1, 0, 1, and 2. And this time, remember, we're having an equation y equals negative x squared. So I do the opposite of x squared. So I square it, right? So I take -2 and square it, which gives me a 4. But I have that negative on the outside, so it's going to actually be a -4. Take -1, square it, I get 1. But again, that negative is on the outside, so I get -1. And then 0 squared is 0. The negative doesn't matter. 0 is neutral. 1 squared is 1, but I got to do the opposite. So I get -1. And I get 2 squared, which is 4. But I got to do the opposite again. So I get -4. And so this time, I still have my 5 ordered pairs. My first ordered pair has the coordinate -2, -4. So I go left 2, down 4. -1, -1. Go left 1, down 1 from our origin. I have the origin, which is 0, 0. The point 1, -1, go right 1, down 1. And then the point 2, -4. All right. I go to the right 2 and down 4. And I have that shape that's very similar to the U that I have up here. The only thing is that it's pointing downward. And I say that instead of pointing downward, I guess I should say that it's opening downward. Okay. And again, I'm sorry about this messy graph here. That's the price I pay for being digital here. But I get sort of what we call an upside down U, all right? But if you look at these two graphs, they are very similar. This one's opening upward, this one's opening downward. There are some properties, all right? This one has a lowest point, all right? We're going to call that a vertex, all right? This other graph has a vertex too, but it is the highest point. All right, when it's the highest point, we call that vertex a maximum. And when it's the lowest point, we call the vertex a minimum. All right, so all of our graphs are going to be opening a certain way, and they're going to either have a max or a min. All right, and I'll tell you how you can figure out whether it's going to be a max or a min or not. Another property about these graphs is that, and it's probably a little hard to tell with the picture that I've drawn here, but if I look at this axis here, this y-axis, all right, if I were to put a mirror on this y-axis and look through one side of the mirror, I should be able to see the other side. All right, so let's say I put my mirror and I'm looking through and I see this side reflected in that mirror. It'll lay exactly on top of that side over there, right? This line right here is called our axis of symmetry. All right, and it always goes through this x coordinate where our vertex is. Not only does that graph has an axis of symmetry, but this graph also has an axis of symmetry. So if I were to put it on my y-axis once again, this line right here will be called my axis of symmetry. And it is a line that we can find the equation of. All right. And so those are two of the main properties that are pretty new to what we've been talking about with relation to parabolas. Actually, that is what we call these graphs. There are parabolas. And this one opens up. And the one down there, it is also a parabola. It's a U-shaped graph. And we say that this one opens down. Okay? And the way that we tell whether they open up or down is to look at whether the number in front of our x squared is positive or negative. All right? So if I look at this example, y equals negative x squared, the number in front of the x squared is -1. And since -1 is a negative number, I'm going to be opening downward. All right? On the other hand, when I have y equals x squared, in front of the x squared is understood to be a 1 since we don't see anything there, which is a positive number, and that's why we're going to be opening upward. All right, so with these characteristics, they're going to be very important in helping us be able to graph parabolas. Now, the first type of parabola I want to graph is one that is much more complicated than the two that we just saw. But they're all going to behave like the ones that I just drew. We just went over. All right? And so I'm going to go to the quadratic equation of the form y equals ax squared plus c. Now, this is different because instead of having it equal 0, we're now having it equal y, which means that we're now in our xy plane, and ordered pairs are our solutions. And one thing that we should always remember about graphs is that a graph is a way for us to show all points that if we were to plug into that function or that equation, it would satisfy it. All right. These are some instructions we're going to take in order to help us graph these parabolas or these quadratic equations. The first thing we're going to do is we're going to determine how the graph opens. And again, we're going to look at the number that's in front of our x squared. And this form here is given by a. If that a is greater than 0, meaning it's positive, then one thing we know that our graph is going to open up. Okay? If a is less than 0, that means it's negative, then our graph is going to open down. So when we draw our graph, we know we're going to have something like that for up, something like that for down, right? The next thing we're going to do is look at this point here, which we call our vertex. Now we have a formula for finding the vertex. The x-coordinate of the vertex is given by -b over 2a, right? Where a is sitting right here and b is sitting there, right? The y-coordinate, in order for me to find the y-coordinate, I've got to plug the x into the function or the equation and it'll spit out the y. And one way to write that is to say f of -b over 2a. We talked about function notation before. All parabolas are functions. And so if I find this x-coordinate, right? This is my x-coordinate. In order for me to find the y-coordinate, which is here, f of -b over 2a, that whole thing is the y-coordinate, not just the -b over 2a. All I do is plug it in, and I'll get the functional value. And remember, our functional values are the same thing as our y values. The axis of symmetry is always the equation, right? So always remember, it is not just a number, it is an equation. All right, it is the equation x equals negative b over 2a. All right, it's the x coordinate of our vertex. So I'm going to go through, figure out how the graph opens, find the vertex, find the axis of symmetry, and the last thing I'm going to do is I'm going to find my intercepts. I'm going to find the x and the y-intercepts. And we remember, to find the x-intercept, you let y be 0 and solve for x. To find the y-intercept, let x be 0 and solve for y. Once I have all of this information, I'll be able to use that information to help me graph the actual equation. Let's look at an example. It says, determine if the quadratic opens upward or downward, find the vertex and state if it is a max or a min, find the axis of symmetry, and find the intercepts. Then sketch the graph. And then this example, I have the quadratic equation y equals negative x squared minus 6x minus 5. Okay? And so the first thing I'm going to determine is how my graph opens. All right? Remember, to find out how it opens, you always look at your leading term, which is that negative x squared here. And since it is negative, I know that my graph is going to open down. Okay? So when I draw my graph, it's going to look something like that. Now I'm going to find my vertex, and this is the confusing part for some people. It is an ordered pair. It is a point. Something that you have to remember, that is this negative b over 2a, comma f of negative b over 2a. All right, and that's just given to you in function notation. So I'm going to first start by finding negative b over 2a, which is my x coordinate. All right, my b is negative 6, so I have a negative 6 over 2 times my a, which is negative 1. Well, a negative 6 is a positive 6, and 2 times negative 1 is negative 2. And so that means my vertex is 6 divided by negative 2, which is negative 3. That's the x-coordinate of my vertex. And so I need to find my y-coordinate, which I plug that into my function or into my equation. So f of negative b over 2a, well, we just found here that negative b over 2a is negative 3. So all I have to do is plug in negative 3 into my equation here, and I'll get my vertex. So I get a negative 3 squared minus 6 times negative 3 minus 5. Okay, that'll give me a negative 9. That's going to be plus 18 minus 5. Now, negative 9 plus 18 is a positive 9, so I get a 9 minus 5, and 9 minus 5 is 4. Therefore, my vertex is the point negative 3, 4. Okay, I have my x and my y coordinate. Now, in this problem, it's asked me to find whether or state whether my vertex is a max or a min. The way I know if it's a max or a min is to determine how it opens. Since it opens down, then my vertex would be here, and it would be considered a max. It's a maximum point. So my vertex would be considered a max point. And max is abbreviated for maximum. All right, after I found my vertex, I'm going to go to my axis of symmetry. The axis of symmetry, right? Again, the formula for it is an equation. It's x equals negative b over 2a. Well, we've already found that negative b over 2a was negative 3. Went up a little too much. Right? Negative b over 2a is negative 3 here. And so it's going to be the line x equals negative 3. Last but not least, we can find our intercepts. I'm going to start with my X-intercept, our intercepts. To find your X-intercept, you let y be 0, right? I'm going to remind myself of this equation here. I have y equals negative x squared minus 6x minus 5. I'm going to put 0 in for y. So I'm going to get 0 equals negative x squared minus 6x minus 5. In order for me to solve for x, I'm going to either use my quadratic formula, complete the square, or factor. I'm going to try to factor. Now, it's a little harder to factor when that first term is your leading coefficient is the negative. So what I'm going to do is I'm going to divide both sides by -1 so that I won't have to deal with that negative out front. A negative x squared divided by -1 is a positive x squared. A negative 6x divided by -1 is a positive 6x. And a -5 divided by a -1 is a positive 5. So I get this equation here. And now I can solve that by factoring. Hopefully I don't run out of space here. X plus 2. That is incorrect. X plus 1 times x plus 5 will give you x squared plus 6x plus 5. I set both of these equal to 0, so I get x plus 1 equals 0 and x plus 5 equals 0. To solve for x, I subtract 1 from both sides in this equation. I get x equals -1. And on the right side, the right equation, I subtract 5 from both sides, and I get x equals -5. All right, so these are my x-intercepts. Now I'm going to find my y-intercept. All right, and we'll only have one y-intercept. You only cross the y-axis one time. And this time I'm going to let x be 0. So I get y equals -0 squared minus 6 times 0 minus 5. And therefore I get y equals -5 because all of this stuff here cancels. All right, and so I have everything I need to graph, and so what I'm going to do is I'm going to go to my graph and I'm going to start putting this information into my graph, and I'm going to zoom out just a little bit so I can see a little bit more. All right, so I'm going to start. I know that it's opening downward, but I don't know where, so I'm going to go to my vertex next. All right, my vertex is at the point -3, +4. So at that point, -3, +4, I'm going to put my point. And I know that's my vertex. It's opening down. I'm going to label my point. That's my vertex. My axis of symmetry is the line x equals -3. Now, this actually isn't a part of my graph. It's just a feature. So what I'm going to do is I'm going to draw that vertical line, but I'm going to dash it in since it's not really a part of my graph. When you go to do your homework by hand, you can write this, but when you enter into MyLabs Plus, you're not gonna graph this in MyLabs Plus. But that's x equals -3. That's my axis of symmetry. Now I'm going to do my x-intercepts. There are -1 and -5. So at -1, 0, I have a point. And at -5, 0, I have a point. And you can see the axis of symmetry. Notice this point here is 1, 2 units from my axis of symmetry. And this 0 or x-intercept here is also 2 units from my axis of symmetry. All right, so the axis of symmetry is valuable in the event that you only knew one other point besides your vertex. My y-intercept is at -5. And so I have this point here. And using that same bit of information about my axis of symmetry, if I wanted to graph another point on the other side of my axis of symmetry that kind of relates or corresponds to this point on this side, this point 0, -5, well, if all I have to do is count how many units this is from the axis of symmetry, right? It is 1, 2, 3 units to the right of our axis of symmetry. So if I go 3 units to the left of my axis of symmetry, staying on that same line, 1, 2, 3, then I'll have another point that I know my graph goes through, okay? And so since I have this bit of information, I can draw my parabola. All right, so I have my axis of symmetry, I have my vertex, I have my x and my y intercepts, and I even found another point right there. All right, and so that's a good example of graphing a parabola. All right, We're going to go to a different type of parabola. And this is a parabola, graphing a parabola of the form ax squared, a times x minus h squared plus k. So sometimes parabolas are going to look like kind of when we started doing extracting square roots. It'll be in that form there. All right. Instead of having to multiply the x minus h squared by using the full method, we're just going to leave it like this, all right? And it's going to be kind of valuable because it's easy to figure out what your vertex is going to be, all right? We're going to go through the same process of graphing this. We're going to determine how it opens. We're going to do that first. It's going to be the same as before, right? So if a, which is this number outside the squared term, so if this a is greater than 0, it's going to open up. And if it's less than 0, it's going to open downward. So that is going to be exactly the same as before. So whatever number is on the outside of that parentheses is going to be multiplied by the x squared, and that's why that works as the same as before. The vertex, instead of memorizing that formula negative b over 2a, comma f of negative b over 2a, here it's going to be h k. All right, it's this number that I'm subtracting from the x here, and then whatever number that is outside of our parentheses over here, either being added or subtracted. One thing you have to note is that it's of the form x minus h, whatever number I'm subtracting from x. So if I'm not subtracting from x, meaning I'm adding from x, then I have to do the opposite. And so it'll be a negative h. We're going to look at an example like that. Our axis of symmetry is still going to be the x coordinate of our vertex as an equation, right? So it's always going to be, since it's a vertical line, it's always going to be x equals, and the x coordinate of my vertex this time is not negative b over 2a, but it's h. And so it's going to be the line x equals h. And to find our X-intercept and Y-intercepts, we're going to do that last before we graph, and then we'll have all the information we need in order to graph a quadratic equation of that form. Okay, and so we're going to look at this example here. Same instructions. It says to determine if the quadratic opens upward or downward, find the vertex and state if it is a max or a min, find the axis of symmetry, and find the intercepts. Then use all of that information to sketch the graph of the equation. In this example, we have y equals x plus 2 squared minus 8. All right. And so I'm going to start with determining how the parabola opens. Okay. The number that's out front in front of this x plus 2 squared is a positive 1. Since that is positive, I know that my graph is going to open up. Okay, and so when I graph, I need to see something that looks like that. If my points don't line up like that, then I've done something wrong. All right, my vertex is the next thing that I want to find. And then this time, we're going to have the HK form. And remember, it's always y equals a times x minus h squared plus k. All right, so the h is whatever is subtracted from the x. Well, here I have an x plus 2. It's not subtracted, it's added. The thing that's actually being subtracted from the x in this example is negative 2, because when we subtract the negative, that's the same thing as adding. Okay? And then the k is always whatever number is sitting out here, right? And so it's going to be a negative 8. So even though this says plus k, right? Well, subtraction is the same thing as adding a negative, so it's like saying plus a negative 8. So this will always be whatever number that you see added on the outside. Since that's a minus 8, it's still going to be a minus 8 here. All right, next we have our axis of symmetry. Remember, your axis of symmetry is always a vertical line. That's why we write it as x equals, all right, from our studies of linear equations. X equals a number is a vertical line, and that specific number is always the x coordinate of our vertex, which is negative 2. Okay, So we know how it opens. We know what our vertex is. Just, it does ask us to state if this is going to be a max or a min. And remember, we can go to how it opens to help us determine whether it's going to be a max or a min. Since it opens upward, we know that our vertex is actually going to be a minimum point. Okay, so that's extra pieces of information that we're given. Now it's time to find our intercepts. I'm going to start with finding my X-intercept. And there may be more than one. There may be one. There may be lots. There may be none. You never know, right? And so remember, to find your X-intercepts, you let Y be 0. I'm going to remind myself of what equation I have here. X plus 2 squared minus 8. All right? So we let Y be 0, and we solve for X. Well, if I add 8 to both sides, I get 8 equals X plus 2 squared. And then I'm going to take the square root of both sides, because I've got to get rid of the squared so I can isolate the X. Remember, when you have a variable expression, you have to remember to put on plus or minus. And that equals X plus 2. Now, to finish solving for X, I'm going to subtract 2 from both sides. And this is one of those situations where we're going to have a complex number, right? I have negative 2 plus or minus the square root of 8 equals X. Okay? Now, that 8 is not a perfect square. We can simplify it, right? 8 is the same thing as 4 times 2, and we can take the square root of 2, right? And so the square root of 4, we can take the square root of 4, which is 2. So we're going to end up with X equals negative 2 plus or minus 2 times the square root of 2. Now, what's not so nice about this example is that this is not going to be a whole number, right? It's irrational. It can't be written as a fraction. It's a decimal, right? And so when we go to graph it in our XY plane, if you look at our graph here, it's going to be very difficult for us to really pinpoint where to graph that. And so what I'm going to do when I have a situation like that is I'm not going to actually graph this. I'm just going to rely on my Y-intercept and my knowledge of my axis of symmetry to help me at least get 3 points. Because when you're graphing these, I always want you to have at least 3 points. And we always know that we're going to have a Y-intercept. Let's find out what our Y-intercept is going to be. Remember, to find your Y-intercept, you let X be 0 and you solve for Y. So we have Y equals a 0 plus 2 squared minus 8. All right, and I want to make sure that I did that correctly. All right. Well, 0 plus 2 is 2, and 2 squared is 4, so I get Y equals 4 minus 8, which equals negative 4, and so that's going to be the point 0, negative 4. All right, so I have all of my pieces of information, and again, when I get to my X-intercept, since that is going to be an irrational number, it's not a whole number, I'm not going to worry about graphing those specifically. I'm going to rely on my vertex and my axis of symmetry along with my Y-intercept to help me get at least 3 points so that I can draw my U or my U-shaped graph pretty accurately. So again, I'm going to start with my vertex. It's at the point negative 2, negative 8, right? So, and again, I'm going to zoom out so that we can see this graph a little bit clearer. Sorry about that. So I get the point negative 2, negative 8. And so here, go left 2 and down 8. It is opening up. So I'm going to label my point here. My axis of symmetry is the line x equals negative 2. Okay, again, that's a vertical line that goes through through our vertex. Again, it is not a part of our graph, it's just a feature of our graph. All right. X-intercepts are decimal, so I'm not going to worry about them. They're not going to help me be as accurate as I can while drawing my graph. But I do have my Y-intercept being at negative 0, negative 4. So from my origin, I'll go down 4, and I have my Y-intercept. Now notice that my Y-intercept is 2 units from my axis of symmetry. So if I go 2 units to the left of my axis of symmetry, I'll have another point on my graph, right? And so I didn't need my X-Intercepts in order to help me be accurate or to have 3 points, one being my vertex and the other two on opposing sides of my axis of symmetry, because I can use my axis of symmetry and my Y-intercept to help me get to those points. All right, and so now here I'm going to draw my parabola as best as I can, and there we have our parabola. All right. All right. The last example I want to look at, it involves an application of quadratic equations. And this application deals with maximums and minimums. Okay. It says that John owns a hot dog stand. He has found that his profit is given by the equation P of x equals negative x squared plus 78x plus 84, where x is the number of hot dogs. It says, how many hot dogs must he sell to make the most profit? All right. So when I see an example like this, I have to make sure that I know what everything means. All right. So again, it says that the profit is given by the equation, right? So if I want to find the profit, then I'm going to use this equation right here. All right, so the profit is given by the equation P of x equals negative x squared plus 78x plus 84. And it tells me that x is the number of hot dogs that I sell. Okay, so if x is the number of hot dogs, if I know the number of hot dogs, then I can plug it into this equation here, and it's going to tell me what my profit is going to be. All right. And so what this says is to find out how many hot dogs must he sell to make the most profit. All right. The key word here is the most profit. All right. So I want to maximize, right? I'm looking for maximum. Most is the same as maximum. Very similar. I want to know how many hot dogs must I sell in order to have the maximum profit. All right. Now I'm trying to find hot dogs, which is given by my coordinate x, or my variable x here, right? And since I'm looking for a maximum, that's always going to happen at my vertex. So what I'm going to do is find the x coordinate of my vertex, and that's going to tell me how many hot dogs I need to sell in order to have the most profit, to make the most profit, right? Remember that your x coordinate of your vertex, when it's written in this form right here, is negative b over 2a. And so I'm going to have a negative 78 over 2 times negative 1. Well, that's negative 78 over negative 2. And that is going to equal 39. So for this example, he must sell 39 hot dogs in order to make the maximum profit. Okay. Part B says, what is the maximum profit? All right, and this is where our equation comes into play now, right? We found the x coordinate of the vertex, right, which is the hot dogs. Remember before I said that if I plug in the x value, it'll spit out or tell me what the maximum profit will be, which is our y value. So all I have to do here is plug in 39 for x into our equation here. Okay, so I'm going to get a negative 39 squared plus 78 times 39 plus 84. And when you plug that into your calculator, you're going to get 1,605. So his maximum profit that he'd be making for selling that 39 hot dogs would be 1,605. All right. And that concludes our video on how to solve quadratic or graph quadratic equations.